Hello everyone, this lecture I'm going to record for term 7 students. We have worked on this workbook for 2 lectures on Friday and Monday. So I just want to record it so that you can revise it again. So what we are going to do in this tutorial, we are going to learn how to characterize crude oil. So crude oil is a mixture of too many components, and we don't know what are those components. By crude oil characterizations, we can know from HYSYS what are those components. What HYSYS will do, based on some lab data, HYSYS will develop some hypothetical components and will show us those components that we can use in our analysis. So this is the pre-treatment of the oil before it goes into the fractionating distillation column, and I will explain you these steps once we go deeper into this tutorial. It will be a little bit longer tutorial as compared to our last tutorials. So what we are going to do, we are going to work on 3 products from our system. We are going to extract kerosene, diesel and AGO, which is automotive gas oil. We must have some properties available for our crude oil in order to work in HYSYS. The first property is given to us is the bulk density. The second property is some liquid volume of the light ends. So the light ends are defined as pure components with low boiling points. So mostly these are ranges from C2 to C5, ethane, propane, butane and pentane. The third thing we need to know is the assay composition. The assay contains all the petroleum laboratory data, boiling point curves, light ends, property curves, and bulk properties. HYSYS uses the supplied assay data to generate internal TBP, which is true boiling point, molecular weight, density, and viscosity curves. Data of the assay in the following table is in liquid volume %. So before I go into next, I just want to mention the reference for this. This one I adopted from Getting Started Manual of HYSYS. It is from version 9 of the HYSYS. It is available in the PDF format there. This example that we are going to work in this workbook. So these are some of the composition of our light ends, which contains methane, ethane, propane, ibutane, n-butane, ipentane, and n-pentane. We do have some assay % and the temperature, corresponding temperatures for them. And this is the data that we will be using for pre-treatment of the oil and in fractionating distillation column. I will explain them one by one when we go up to those points. So let's start with the HYSYS. What we are going to work on, we are going to add our light components, which are methane, ethane, propane, ibutane, n-butane, and ipentane and n-pentane. So let's start with HYSYS. So I went to my component list and I click on add. So I have methane, I have ethane. So what I'm doing now, I'm pressing shift here and I'm selecting all of them together. You can do them one by one, it's the same thing. Once you have selected your component, just click on add. Now if you look on our system here in my sheet, I need a water here as well. So let's add water. So once I have all the components available, the next is I need to choose the fluid package. Go to the fluid package, click on add. For such system, the Peng-Robinson is most appropriate. So I click on Peng-Robinson. HYSYS is okay with my fluid package, and next I need to add these properties which I just showed you for my assay. These are the properties that I need to add, and how we do that, just look at this first. So these are our items here in the properties. If you go on the status, you can also see what are the problems associated with this, and HYSYS is okay with our current system so far. And let's go back to the all items again. So in order to add the properties of the bulk and our assay, what we need to do, we need to click on oil manager. If you're not able to see the oil manager here, you can also click on the oil manager, which is available on the home tab of HYSYS. So I click on my oil manager, and here you need to click on input assay. Once I click on input assay, click on add here because we want to use some properties here. Now we do have the data available in the bulk properties, so we want to use it. Just keep in mind, the more properties of your crude oil are available, the more accurately HYSYS can predict those components in your crude oil. So right now I have three properties. One is a bulk properties. I do have Assay as a TPP, and I do have the light ends. As you can see here, I can either provide input or I can auto calculate, and I'm going to input my composition. Once you select your all details here, I don't have molecular weight curves, I don't have density curve, I don't have viscosity curves for my crude oil, but I do have these three properties. Once you select these properties here, on the right hand side it will develop your input data. So let's start with the bulk properties. Click on bulk properties, and here I can add my density. So I went back to my workbook here. So my bulk density is 879.8 kilogram per meter cube. So this is 879.8 kilogram per meter cube. Now before I hit enter, I just want to show you, sometime you will be given the API gravity for your crude oil. If it is the case, you can just choose this API. API is taken as the ratio of the 60 degree Fahrenheit or 60 degree Fahrenheit. So this one you can choose it, but for now my given property is in terms of kilogram per meter cube. So I have selected this. Next, go to the light end components, and here I'm going to enter all the compositions that I have in my workbook. However, just make sure that you have the right units chosen. For my system here, I do have that in terms of light compositions. So these are the compositions that I need to add in my next HYSYS. So the methane is 0.0065, ethane is 0.0225, and propane is 0.32, ibutane is 0.24, n-butane is 1.75, and ipentane is 1.65, and my n-pentane is 2.25. So I just want to double check I have the right compositions. Methane 0.065 and pentane is 2.25. So I have entered my all compositions. The next is I need to go to my distillation here. Again, this assay percentage, which is the next table in my workbook, this one has these percentages are in terms of liquid volume, as you can see here. So these are given in terms of my liquid volume. So in my next step of the HYSYS, I will enter these into my simulation. So I will choose liquid volume here and click on edit assay. Here it will ask you how many data points you have. If you count them, these data points, they are 12 in number. You can stop the video and count them, and that's what I'm going to do. So I have 12 of them, and click on add data points. It will develop 12 rows for you in order to enter your data. And now in the next step, I'm going to enter this data into my table here. I do have the print of this available, so I'm just looking at that and entering here. But you can stop the video and enter those data. So I have entered my data into my assay input table, and then I just click OK, and you can see that the table is ready here. However, it has not calculated anything. So you can see that if I go to my working curves, there is nothing calculated. What you can do, just click on the calculate here, and now the assay was calculated. So now I have all the properties and the components. So once I click on the calculate, it will calculate the moles, normal boiling points, molecular weights, mass densities of my components here. After that, just go to your output blend, click on this and click on add. Once you have developed your assay, we need to enter that into our simulation. How we do that? We move this available assays into oil flow information. Just select this assay and click on add. Now we have added our assay into the oil information, and as you can see that it is saying that your blend was calculated. You can also see what are those components here. So these are the components, hypothetical components that HYSYS has developed, and their corresponding NBP, which is normal boiling points, their molecular weights, their density and viscosities. We can also look on some other properties here. Let's say I want to see what is the TBP. Then this is the temperature profile with respect to the volume percentage for my crude oil. I can also look on the distribution plots. Here I just want to explain you what is this. So if you look on this one, it is the boiling point saying that 368, and this boiling point is 820. So in my crude oil, most of the components, because this is the highest one, most of the component whose boiling point is between 367.1 degrees Celsius and 823.7 degrees Celsius, they have the higher composition, because I can see that my curve is my plot for this composition is the highest as compared to rest of them, and the least I can find in my crude oil is a material or the component which has the boiling point from -20 degrees Celsius to 7.93983 degrees Celsius, because I can see that it has very less liquid volume fraction. So this is the highest I can expect in my crude oil, and these are the least one I can expect in my crude oil. We can also go in the table and we can look for some properties. For example, I want to see what is the molar composition. So these are the light ends which I entered here into HYSYS, and based on my hypothetical components, these are the composition which HYSYS has developed in the crude oil. So this is how you develop your crude oil composition. Now let's go to the data here. How do you attach that? You need to click on install oil, and here you need to provide the name of your stream here. So it is my crude oil. Type crude oil here and click on install, and it will automatically install into your simulation environment. So once you are done with the assay and the blends, then we can move into our simulation environment. As you can see that when I move into my simulation environment, it has already created a crude oil stream for me. If I double click on this, if I double click on my crude oil here, I can see that these are all the composition which we just looked at. If you have any particular composition available, you can just edit this and enter that composition here. Just make sure the sum of all composition equals to 1 here. Now let's go to the data sheet and let's do them one by one. So my crude is these are the properties of my crude oil. It has a temperature of 15 degrees Celsius, and it has a pressure of 1000 kilopascal, and the mass flow is 6 into 10 raised to power 5. So let's enter this information. So again, I just double click this, and my temperature is 15 degrees Celsius. My pressure is 1000 kilopascal from my sheet, and my mass flow rate is 6 into 10 raised to power 5. 6 into 10 raised to power 5. How you show that 10 raised to power 5 in HYSYS? Just press E and the power, which is 5 here. So I just want to check it again. So my mass flow rate is 6 into 10 raised to power 5 kilogram per hour. As you can see that it is still saying that it is unknown rate here, but I have entered all the information. How you can fix this? Just go back to your HYSYS, and you can see that it is on hold now. I just need to click on active, and it has calculated the rest of my properties for the crude oil. And again, this composition is here, and it has calculated other properties related to crude oil. So I can close this and go back to my sheet again. The next is in my system here, as you can see that I'm entering water, and water and the crude oil are getting mixed. So the water is at 15 degrees Celsius, and we do have the flow rate given for the water. So let's enter this information. I need to bring in a stream, and this stream is named as the water, and water is present at 15 degrees Celsius, and the flow rate of the water is 21600 kg per hour according to my sheet. And the composition, because it is only the water, I just click 1 here, press enter. The rest of them are supposed to be 0, because the water stream you can just click normalize, or you can enter them one by one, or you can click just normalize and press OK here. Now it is giving me the signal. We have unknown pressure. That's okay. Just close this and move to the next step. HYSYS will automatically calculate its pressure. In my next step, I have a mixer, and the output of the mixer stream, I will give them the same name as in my sheet here, is 2 heater. So I go to my sheet here and I bring in this mixer. I'm mixing my crude oil. It is my crude oil here, and I'm mixing my water here. The outlet, as I mentioned, I will give it the same name as in my sheet. It is named as 2 heater. And for the parameters, we need to equalize the pressure. Now as you can see that mixer has converged, and now it has also defined the pressure of my water stream, which is 1000 kilopascal. So I have worked up to this point of my simulation. The next is I have a simple heater number 1, and for this one, if I go to my data here, these are the properties given for my heater here. So my delta P for the heater is 50 kilopascal, and the temperature outlet is 65 degrees Celsius. So let's design this. We go to the HYSYS and bring in our heater here. So this is 2 heater, and the energy stream which is named as H1Q according to my PFT which I just showed you, and the outlet is named as 2 heat exchanger. You can provide any name, but I like to stick to the names which are in our sheet, so that if we have to do some debugging with the HYSYS, it is more easier. So the outlet of this is 2 heat exchanger, and again we have the delta P of 50 kilopascal, and the pressure temperature is 65 degrees Celsius. So if I go to my parameter, my delta P value is 50 kilopascal, and I want to have a temperature of 65 degrees centigrade at the outlet. And now as you can see, it has converged. So I have defined my heater here. The next operation in my PFT is this is going to a heat exchanger where we have a hot pump around and we have the cold pump around, and the outlet name is to desalter. So let's look on the data sheet. So this is my heat exchanger, which is a shell and tube heat exchanger, and it is used to preheat the crude at 100 degrees Celsius. The pressure is given to us and the volume flow rate is given to us. Now here you need to look at the crude is what is entering into our heat exchanger. So we want to have the same composition of this stream as we had in the crude. However, we don't want to have temperature, pressure and the liquid flow rate. Why? Because it has already been defined in our data book. And for the heat exchanger, the minimum approach is 30 degree Celsius. I will come back to this later when I work on the heat exchanger design. So let's go to the HYSYS. I can just reduce it and make some space for myself here. So my heat exchanger is a shell and tube here. I bring that in, and now the inlet of my tube is basically this stream which is coming to heat exchanger, and the outlet of my stream is, if I go back here, the outlet of the tube side in which we have the crude oil, it's named as to desalter. So this is named as to desalter. And from the shell side, if you look on our sheet here, it is saying that hot pump around, and we will do the same. It is hot pump around, and for the outlet of the shell is the cold pump around. So we have defined our streams here, and now I can close this and work on my this hot pump around stream. As I mentioned, it must be the same as our crude oil composition. So how you do that? You can just double click here, and either you can enter these composition manually, or there is a short way that we can do on. If you go to this conditions here, let me expand this here. Here just click on the define from stream, and we want to use the crude oil here. Click on the crude oil. We do have the temperature, pressure information available for this stream. We don't want to get it from the crude oil stream, so just uncheck this, uncheck your pressure, and we do have the flow of the stream as I just showed you here. We do have the flow rate as well, so we don't want to have the flow as well. The only thing we want is the composition, which is this one, and click on OK. So what will happen? HYSYS will bring all the composition of your crude oil stream into your new stream, which is this pump around here. However, we can define our condition. So the temperature of this stream is 180, pressure is 200 kilopascal, and the liquid volume flow rate is 175 meter cube per hour. So the temperature here is 180, the pressure is 200 kilopascal, and my volume flow rate is 175 meter cube per hour. As you can see that HYSYS has converged my stream. This means I have provided all the information, and these are the compositions that I am using from the crude oil. Now let's go to our heat exchanger design, and we will define the minimum approach. What is the minimum approach? It is the minimum temperature difference between hot and cold stream. So this is the definition of our minimum approach, which is 30 degrees Celsius. So let's double click on this, and in our heat exchanger we have no pressure drop given. So this means my pressure drop, go to the parameter, and pressure drop is 0 for shell side, and it is 0 for our tube side here. Once you have done this, go to the specs, and here we need to define our minimum approach. Click on add, and from this type just select on the minimum approach, and we are having that value for overall heat exchanger. Click on overall, and here we type the value, which is 30 degrees Celsius, and hit enter. As you can see that HYSYS has converged my heat exchanger. Now I have all the properties for my input streams, output streams, tube side, and both tube side and shell side. So I can close this now. Next we go to our, these are some of the connections details I provided so that it is easier for you to correlate them. Next, when I go to my sheet, I do have this separator, which is a desalter basically. and in order to provide this desalter in HYSYS, it is as a three-phase separator. So this is my three-phase separator. I click on this. So the input of this is to desalter, and for vapor, let's say we give it a name of vapor stream, and the liquid stream according to our sheet is called as a crude, and the bottom is the desalter water. So my liquid is crude, and my bottom is the desalter water. And now this has been converged. I just want to mention in this diagram, which is adopted from HYSYS example, they missed to provide the vapor stream here. So this needs to be there because it's a three-phase separator. So we can click this, and now we have defined our desalter here. You can also change the name, but for now I'm just using the stream's name accurately. Next in the line is our heater here, and let's go to our data sheet and see where we can have these properties. Yeah, so this is our heater. I will just give it again the red color for the heater. So the pressure drop is 375, and the pre-flash temperature we need is 175. And for this heater, the input is a crude, and the name of the output stream is to pre-flash. So let's bring in the heater here, and this is coming from the crude. The energy stream name is H2Q, and the outlet is to pre-flash. The drop-in pressure according to our sheet is 375 kilopascal, and our outlet temperature that we are looking for in the stream is 175 degrees Celsius. Let's double check and confirm that we are doing it correctly. Yeah, 175 is your temperature of our outlet, and delta P is 375. Let's go to the next equipment. In the next equipment, we have this separator here, where we have liquid product on the top, and we have the bottom liquid coming as the outlet. So let's go to the HYSYS again. So we need to provide a separator here. So this is my separator, which now let's save this file before we move next. We save as, and this is let's keep it on the desktop. So in our separator, we just double click on this. The input stream of the separator is our to pre-flash, and the outlet according to our sheet is liquid product, and this liquid stream is the bottom product, which is the main crude oil here. Okay, so this has been converged now. So I have two streams here. Let's make a space more. So what we have done so far, this is our system so far, and we can also I think it is better now. So this is our system starting from crude oil up to the bottom liquid. So let's go to the next section, and let's save it before we go next. And in our system here, in the next one, we have this is the heater, simple heater that we have used, and in our next system we have the furnace. and these are the requirements, design requirements of that. Let's use it some other color for this. So my heater is 250 kilopascal, and the feed temperature, which is outlet stream, it is at 400 degrees Celsius. So I will show you what is here. So this is my heater, and this one I want to have at 400 degrees Celsius. So we go to the HYSYS here again, and let's add heater here again. We have the heater here, and it is connected to the bottom liquid, and the outlet name of this stream is the ATM feed in my sheet here, and this energy stream is H3Q. According to our data sheet, it has a 250 kilopascal drop in pressure, and we want to have a 400 degree Celsius of our outlet stream here. So as you can see, my HYSYS, my heater has been converged, and now this ATM feed is ready to go into the distillation column. Before that distillation column, I just want to explain you some points here. So we are going to separate our three products, kerosene, diesel and AGO. For these three products, we will have some side streams associated with them, which are called as the SS side streams. So in order to use those side streams, we must have three streams according to this sheet, which is named as the bottom stream, diesel stream and AGO stream, which has steam going into them. And which are those streams I'm talking about? As you can see that this is here diesel stream, bottom stream and AGO stream. So we need to develop three material streams, and the data of these material streams is given here. This is for my bottom stream, and these two are for my diesel and AGO. So let's do them one by one. So first I bring my three material streams into the environment. 1, 2 and 3. The first one is named as bottom stream, and according to my data book, it has a vapor fraction of 1, the pressure of 1380 kilopascal and the flow rate of 3400 kilogram per hour. So this for the bottom stream, my vapor pressure is 1 here, and my pressure is 1380, and the flow rate is 3400 kg per hour. Because it is a steam, we'll go to the composition and the water will be 1 here, and the rest of them are 0. Either you can add them one by one, or you just click on normalize. It will make them 0, everything here except your water, and just click on OK. We have defined our one of the streams. Now let's go to the next stream, which is the diesel stream. It has a temperature of 150, pressure 350 kilopascal and the flow rate of 1350 kg per hour. So just double click on this, and this is my diesel stream. According to our sheet, the temperature is 150 degrees Celsius. The pressure is 350 kilopascal, and my flow rate for this one is 1350 kg per hour. I just want to double check this. Yes, it's 1350, and because it is steam here, its water composition is 1, the rest of them are 0, and click on OK. Now we have defined our second stream, which is the diesel stream. For the third one, we have AGO stream here. We have pressure, temperature and flow rates given to us. Temperature is 150 degrees Celsius, pressure is 350 kilopascal, and the flow rate is 1150 kg per hour. So let's go here, and this is my third stream. This is named as the AGO stream. The temperature for this one is 150 degrees centigrade. The pressure for this one is 350 kilopascal, and the flow rate is 1150 kg per hour. And if I go to my composition, the water is 1 here, and click on normalize, and then click on OK. So up to this point, what I have done, I will take you to my sheet again. So up to this point, I have defined these three streams which has the steam water in them, and now I need to work on my distillation column. If I go to my sheet here, again this example is adopted from HYSYS manual. This column is basically a reflex absorber, and these are the number of stages 29, and the feed is entering at stage number 28. And the bottom stage inlet is the bottom stream. I will show you where I use this information. So let's start with the bringing in the column, which is a reflex absorber. You go to your sheet, and please allow me to save this one, just in case I lose this. So go to the separator, and this is the reflex absorber. We bring that into our simulation, and we will double click here. Let's name the streams. So the condenser energy stream, let's say we say it a name of the QC, and condenser is working on the partial operations. And here, if you look on my sheet diagram here, what I'm getting off gases, and naphtha is coming as a distillate from my system. So this is off gases. The overhead outlet is my naphtha. And we will click on water draw, because if we want to prevent two liquid phase formation in the column, we must use the water draw here. So I will give it a name of waste water, and you can also see this in our sheet here. So this is my waste water stream here, and the bottom is the ATM residue, and my bottom here is the ATM residue. And the feed which is ATM feed here, and this is where I will use one of my stream, which is my bottom stream here. And according to my sheet here, according to my data sheet, we have 29 plates, and the feed is entering at 28th plate. So we have you need to change the number of plates first, only then you can select the inlet stage. So we have 29th stage here, and this is 28. So far we have defined everything related to our column input first page, and the next we will go to our section here. Here it is asking what are the condenser pressure and condenser drop-in pressure and the bottom stage pressure. So let's go to our sheet here, and on the next page, which is page number 4, we have these properties. So I do have condenser pressure 140 kilopascal, the condenser pressure drop is 60 kilopascal, and the bottom stage pressure is 230 kilopascal. So let's enter this one. My condenser pressure is 140 kilopascal, my drop-in pressure is 60 kilopascal, and the bottom stage pressure is 230 kilopascal, and then click on next here. In our sheet, we also provided the condenser temperatures, the top stage temperature and the bottom stage temperatures. Now I'm going to add this information into HYSYS. So my condenser temperature is 40 and top stage is 120 degrees Celsius and my bottom is 340 degrees Celsius. So let's double check these information. 340, okay, and click on next here, and we don't have this information available, so just click on done here. Once you have provided this information, HYSYS will open the main window where it will ask you some more information. Now let's come back to our objective here again. So we are separating three products, which is the kerosene, diesel and AGO, which is automotive gas oil, and in order to separate them we must develop some side streams for each product, and this is the information associated with them. This is the information for side stream. So I have AGO stream, side stream, these are properties for AGO, and I have the diesel side stream and the kerosene side stream. The thing which I want to highlight here, this is the draw stage number 22. That means from the main column, which has 29 plates in it, from plate number 22 we are drawing some product, we are removing our AGO product from that, and then from plate number 21 we are returning the leftover product to the main column. And how we work on that, just go to your simulation again. Over the main point here you will click on the side operations, and on the side stripper just click on add, and here we can provide some information. Now if you understand or allow me to explain you a little bit more, this is the tiny distillation column which is associated with the big distillation column. By that I meant to say there is a main distillation column on this side somewhere, and we are drawing some liquid, we are removing our products, and we are returning that to the main distillation column. And according to that, according to our workbook, we will work on AGO first. So this is AGO side stream. So this is my AGO side stream, and on what stage I am drawing it from the main column, which is on its left hand side. So I am drawing it on 22 and I am returning the fluid on 21 stage number of the main column. So I am drawing it on 22 and I am returning it on 21. Now for the reboiling system, as I said, this is a tiny distillation column which is called as the side stream. It also have some heating mechanism, of course. It could be either reboiled system or it could be either steam stripped. So as you can see that this is reboiled, so I have a reboiler here, or I can select as a steam strip. Which one is for our system here? It is saying that this is my steam stripped. So I'm gonna use this information. And how much is the product flow, which is 30.69 meter cube per hour. So let's go to our AGO side stream. In this one I need to choose my stream here which I develop for AGO. This is my AGO which is going inside my tiny distillation column, and the product which is coming out is we need to provide this as a we need to make a new stream which is AGO product. So just to mention that this is not called as a tiny distillation column, I am just explaining you to understand this. This is called as a side stream column, and the flow rate is in terms of volume, I believe, which is 30.69, but here I have the molar flow. How we can change it, just select the ideal volume here, and this one should be 30.69 meter cube per hour. Hit on enter and click on install. It will automatically add your system into the side operation stream, and now we can close it. Now the same procedure I'm going to repeat for the diesel side stream and the kerosene side stream. Again, we are drawing it at the stage 17, we are returning it on 16, and this is a steam stripped stream here. The flow rate is 128.88 meter cube per hour. So click on add, and this one is my diesel side stream. I'm drawing it on plate number 17 from the main column, and I'm returning it on plate number 16. And again, this is my steam stripped, and here I will select the diesel stream which I developed initially, and I have the volume flow rate, and this one is the diesel product now. And the flow rate here is 128.88 meter cube per hour. I just want to check the flow rate again. Yes, it is 128.88 meter cube per hour, and now you can click on install here. So this is done. The third stream in our system is the kerosene oil, and now here you can see it is used as a reboiled, and we are drying it at stage 9, we are returning it at stage 8 of the main distillation column, and the product flow is 64.10 meter cube per hour. So let's work on it. Click on add, and this one will be my kerosene side stream. I'm drawing it at plate number 9, and it is being returned at plate number 8. This time I'm using the reboiled type instead of the steam stripped according to my data book. As you can see, it is reboiled type, and it is still the volume flow is given to us, and here we can say that this is my kerosene product. And volumetric flow rate is 64.10 meter cube per hour, and click on install again. So it has installed my 3 side streams. Now once you have installed your side stream, you must provide some pump around mechanism for each stream here. So now we are going to work on developing the pump around mechanism for these streams, and the draw stage and the return stage will remain the same. So this is my AGO pump around. We have the flow rate value and we have the duty. So let's go to the HYSYS, and now we click on pump around and click on add, and let's start with the first one. So this one I'm going to do for AGO pump around, and the draw stage is 22. This is basically the cooling mechanism that we need to provide to our distillation column, and we are returning it on 21. Let's look on the sheet again and confirm this. Yes, we are drawing on 22 and we are returning on 21. We do have 2 properties, which is molar flow rate 200 meter cube per hour, and the duty is minus 3.7 into 10 raised to the power 7 kilojoule per hour. As you can see that this is in negative. This is what I told you, that we need to draw the energy from our distillation column, and this is why we provide our pump around in the column. So let's go to HYSYS. So my draw stage is 22 and my return stage is 21 according to this, and click on install here. Now here we need to provide these 2 properties. The first one is the volumetric flow rate, and over here you will choose your volume flow rate, which is 200 meter cube per hour, and just close this one. The second property which is given to us is our duty, which is minus 3.7 into 10 raised to the power 7 kilojoule per hour. How we work on that? Just click on this. Here there are different specifications depending upon your problem. You may choose some other things, But now right now I have the duty given for this, and enter the value minus 3.7 into 10 raised to power 7. How you do that again? Just click on E and 7 here. It will enter that value into our system, and now you can close this. So I have defined my pump around for AGO here, and now I can close this. The same procedure I will repeat for the rest of the two, which is my diesel pump around and my kerosene. Again, we are drying the diesel at 17, returning at 16. The flow rate is the same, minus 200 meter cube per hour, and the duty is the same as for the AGO. So let's work on this one again. The same procedure. Click on Add. Diesel pump around, and we are drying it at the stage 17, and we are returning it at the stage 16. Then click on Install, and now here we need to provide our properties here. According to my sheet, my flow rate is 200, so here I can just type in 200. Now again I need to just double click on this, and I need to change my units here. So volume units here, and 200 meter cube per hour. Now it is good. If you have the molar flow, you can provide that, but now because I have the volume, that is why I choose this. Close this, and in the next one I have the duty given to us, which is minus 3.7 into 10 raised to power 7. And you can close this, and now we can close this. So we are good with the diesel pump around, and now let's go to the kerosene. So we are drying it at stage number 9, returning it at stage number 8. The flow rate this time is 330 meter cube per hour, and this is the amount of the energy we are removing through this pump around. So let's work on this one, the last column here. I click on Add, and this is my kerosene pump around. I'm drying it at the stage number 9, and this is returning at the stage number 8, and click on Install. And for this system, my flow rate is 330 meter cube per hour, and my duty, which is given as minus 4.5, 10 raised to power 7. So we are all set with the information of pump rounds because we are dealing with the 3 side streams only. Now let's go to our sheet again. Here we need to provide last specification. The overhead vapor rate is 0 kilomole per hour, and the distillate rate, which is naphtha rate, it is 104.3 meter cube per hour. So let's go this, and we go to the design tab here, and in the design tab, if you look at the monitor here, now the degree of the freedom is 0. This means if I run my simulation, it should work. However, we must provide our information in the specification, which is these two information. How we work on that? Just go to your spec summary here, and this is here. Anything which is ticked here, that is what is active in the calculations, and anything which is not ticked, HYSYS is not using them, but HYSYS will calculate those information for you. So we want to provide the 0 kilomole per hour for our vapor product. As you can see that this was the information given to us, this information here, and the next information we want to provide is the distillate rate. So you go here and you provide the distillation rate, which is 104.3 meter cube per hour. So my distillate rate is 104.3 104.3. Now as you can see that my units are kilomole per hour. How you can change it, just double click on this and it will open up a small window where you can select your volume units, and the volume is again 104.3. so I have provided this information. Now because I don't have the reflex ratio, I can just uncheck this and I can select my vapor products here. As you can see that the time I made this change, HYSYS has converged my distillation column, and now I can go back and see that my distillation column has been converged. So this means it has solved all the streams here for me. You can just arrange them and separate them. If you want to see what is the more detailed view, just click on this, and over here you have the enter subflow sheet. I'm going to unselect this and show you. This will never be highlighted if it is not selected, so you need to select the distillation column. I will select it and you can see that it has provided more details, and you can enter into your environment here. Let's close this, and now these are those side streams that we were developing in our distillation column. This is my kerosene here, this is for my diesel, a tiny unit, and this is a tiny unit for my AGO, and this is the condenser for my main distillation column, which has 29 plates into this. So these are some of the more details here. If you want to go back, just click on go to the parents, and we are back to our distillation column. I just want to explain you something here. As you can see that we have these properties here, so you can also analyze the performance of your distillation column, how the off gases, naphtha and the wastewater, ATM residue, kerosene, diesel and AGO products were performing. So these are all their composition, how they were changing in different streams. We can also look on some column profiles here, and with the trace, how the temperature was changing, how the pressure was changing. The more beneficial is to have the plots here. We can just click on the view graph, and as you can see that this is the variation of the temperature. If you recall, this was the point where we were entering our stream, and this is the temperature variation. We can also work on and look on the pressure graph within the column, and this is our pressure graph. If you want to export this out of the HYSYS, just right click on this, click on print plot, and it will ask you the destination where it can save it as a PDF. So for now I'm going to cancel this. And last thing which I want to mention before I wrap up this is we have done internal sizing in our lab in term 7 here. So I would suggest you, as you can see that these are the streams which we were drawing from our column. If you look on AGO from 22, diesel from 17 and the kerosene from 9. So what I would suggest you, these are the different streams that we are drawing from the main distillation columns. What I would suggest you, just go through the lab and perform internal sizing of this distillation column. Last thing which I want to mention you, as you can see that it was a very detailed work only for 3 side streams. In reality we have around more than 100 products in a crude distillation column. So this is why the size of oil and gas industry is too big, because it involves too much designing, and plus the actual size of the equipment and the space they needed in the refinery. So I hope this helps, and if you have any questions you can email me, or if you would like to see me for any further understanding of the details, you are also welcome to stop by in my office. And this is the final view of our pre-treatment of the crude oil in HYSYS, and plus the fractional distillation. So I hope this helps, and thank you very much.